In this video, we are going to talk about compounding. Compounding is confusing for some people, but it's really quite easy. Compounding doesn't have to be on an annual basis. You don't necessarily collect interest at the end of a year and then collect interest on the original principal plus interest for the next year. Sometimes you collect interest at the end of every 6-month period, for example, corporate bonds, quarterly, for example, stocks, or monthly, mini savings accounts, sometimes daily, again, many savings accounts. So the present value, future value formulas all work exactly the same way as they do for annual compounding, except that the interest rate you put in is the interest rate per period, per month, per day, per quarter. And the number of periods is the number of months, days, quarters, and number of periods. For example, if you had $1,000 in a savings account at 6% interest, for 5 years, and you earn interest on it for 5 years, compounded annually, you would collect interest 5 times at 6%. That would grow to $1,338. If instead you collected interest semi-annually, you would collect 3% every 6 months, but you would collect that interest for 2 times 5 or 10 periods. That would grow to $1,344. Why? Well, you start earning interest on your interest sooner. The $1,000 at quarterly compounding would grow at 6 divided by 4. It's 1.5% every quarter for 4 times 5, 20 quarters. That would grow to $1,347. And collecting interest daily by convention a year is either 360 or 365 days, depending upon the kind of account you've got. It would grow to $1,350 on a 365-day year. Present values are also affected. If you had a zero coupon bond where you would collect $1,000 in 5 years and discount it back 5 periods at 8%, 10 periods at 4%, 20 periods at 2%, accounting for compounding, the present value would drop every time you compound more often because the effective interest rate is higher. Now, what you need to do in order to understand compounding problems is just keep track of 3 things. First of all, the annual percentage rate is the rate that holds over the course of a year without compounding. Because of the truth in lending and the truth in savings acts, you always have to be quoted an annual non-compounded rate. The rate per period is the APR divided by the number of periods in a year. So you would divide by 12 if it's monthly compounding, 4 if it's quarterly compounding, etc. But the effective rate you get over the course of a year includes compounding. This is known as the yield or the effective annual return. What I want to show you is the relationship between the annual percentage rate and the effective annual return. So the annual percentage rate is the rate you pay every, say, month, times the number of months. Or the other way around, the rate you pay or receive per month is the quoted rate divided by number of months. So if you're quoted 6% on a savings account, with monthly compounding you would get 6 divided by 12, 0.5% per month. That's called the periodic rate. Now, what we do for the effective annual rate, the yield or the compounded rate, is we take that interest rate we get per period, pretend like we invest $1 for exactly a year. If we do that, we'll have compounding on that $1 for a year for the number of periods in the year. If we subtract that dollar back out, we end up with the interest we earn over the course of a year. And we can go the other way. If we know the effective annual return, just invert the equation, uncompound it for, say, 12 periods, subtract 1. So the relationship between the annual percentage rate, the periodic rate, and the effective annual return is the periodic rate is the APR divided by 12, 52, 365, 4, number of periods in a year, and then you have to compound that 12, 2, 365, number of periods in a year to get the effective annual rate. So let me give you an example. Our mortgage is at 4.75%. It's annual. We make monthly payments. What is the periodic rate that we're paying on this loan? Well, you would just take the 4.75% and divide it by the number of periods in a year, 12. That's the periodic rate. Let me do that on the calculator. That's 0.3958%. Now this is the critical rate. This is the rate that you use in the annuity formula to figure the payments. If I want to figure out what the effective interest I'm paying over the loan over the course of a year is, accounting for compounding, what I need to do is compound this by the number of compounding periods in a year. Monthly payments, take to the 12th power, subtract 1, and I get the effective annual return. So let's see, 1 plus this, compounded for a year. It's always going to be compounding for a year. It's 4.85. Let's see, 4.855. So you can see that even though my APR is 4 3/4, and that's what they have to quote to me by law, I'm actually effectively paying more for that after I account for compounding over the course of a year. Now this compounding creates a small increase for a small number of periods within a year and small interest rates, but if you're paying interest frequently and the interest rate's very high, for example a 1-week payday loan, compounding really adds up quickly.